Hello everyone, my name is Ryohei. Today I will talk about this title. This is outline of my presentation. Introduction. In recent years, digital archive of cultural assets has been studied in order to preserve cultural heritage in the world. It is various cultural assets. Example, painting, building. We studied by focusing on Ion Festival in Kyoto. Also, three-dimensional shape measurement technology is progressing. In addition, ultra-high resolution photo images are becoming popular. These data have been used to digital archiving. As the way of the usage of these data, there is transparent visualization. Until now, it was visualization of only superficial appearance. However, we can see through deep inside of objects by transparent visualization. In addition, by the taking of ultra-high resolution image is possible, we can see image in more detail. So we should properly switch over the resolution at that level of details. Based on this study's background, we have focused on ultra-high resolution image. We propose multi-resolution transparent visualization of ultra-high resolution tapestry photo images of the Funeboko float in Gion Festival. The purpose of this study is selection of proper resolution according to users' request. Next, I will talk about method. We use PBR to transparent visualization. PBR is enabled to point rendering. It is possible to direct use of the measured point cloud for visualization. In addition, it is possible to be transparent visualization of a large-scale point cloud without rendering artifacts. I will explain about the PBR algorithm. PBR is done in 3 steps. First step, it generates particles. Next step is project particles. We repeat these 2 steps several times. Last, this result average and determines the brightness value of the pixels. The below images are actual example of the transparent visualization. When we transparent visualization using PBR, the opacity is determined this equation. Small s is particle cross sectional area, and repeat level is number of averaged image. This parameter is to ensure the image quality. Therefore, we think large S and N as as parameters to control the opacity. I explain the multi-resolution in PBR. The image that we displayed on the screen is resolution region that projects to the camera. The expansion in PBR, it does not mean to enlarge the region. It looks as being enlarged when projected by the camera comes close. By camera zooming, we can focus on a smaller region, which higher resolution. The particle number is determinant to fit the opacity of region projected to camera at first. In simply camera zooming, particle size is enlarged. It sacrifices the visualization resolution because it changes smallest. In this study, the resolution must not become lower because we use ultra high resolution image. If we keep the particle size, the resolution is maintained. However, we cannot keep opacity instant because particle density become sparse. So we need to proliferate particles to supplement density. Therefore, we propose particle density control of the region of interest. First, user prepares multi-particle set of target resolution. Next, user select of a resolution of interest. It means select resolution. Thus, user select proper particles set that has the resolution and the opacity of step 2. As a result, it's possible to maintain the opacity. As a verification experiment, we desampling the photo image and convert the image to particle data. There are result image. In previous method, opacity is decreasing each time to enlarge. On the other hand, in proposed method, the opacity is maintained always. From this result, the proposed method will be considered valid. Finally, I will talk about result using the actual measurement data. We use two visualization data for experiment. One is laser scanner point cloud data, plot. This is one of the plot in the parade of Gion Festival. This is nationally designated important cultural asset. Another one is ultra high resolution photo image of tapestry, Shimomizuki. This picture have several hundred million pixels. So it is fineness of 0.1 millimeters 1 pixel. This here enlarged image is here. It is result image that transparent visualization and fused to image and to data. So I expand the range of data frames. In the previous method, it not able to maintain the opacity at all. The other hand, the purpose method, so purpose method can maintain the opacity. Let me summarize point of my presentation. We propose multi-resolution transparent visualization of ultra-high-resolution photo image. Its approach is particle density control of the region of interest. As a result, it is possible to visualize in more detail. As future work, there are speed up the current interactive speed visualization to real-time visualization, and make application to digital museum contents. Thank you for your attention.
Any question? You call it a particle visualization method. What is the particle?
Particle is like pixel of image, pixel of it like.
I mean, are you using photons? Are you using electrons? Are you using beta particles? What is this? What is particle?
In 3D sharp measurement. In 3D sharp measurement, so laser scanner point is particle.
Okay. So you're talking about the object you're scanning,
Yes.
not the scanning method.
Yes.
Okay, so you're scanning using light. You're using photons,
Yes.
is what you're receiving. But the particle scanning refers to the level at which you are visualizing. Is that correct?
Thank you for interesting talk. Your main point is the transparency, but I think the cultural asset, which includes Yamaboko, does not have transparent part. Probably Yamaboko object includes no transparent part. So could you explain why transparency is so important for your research?
In this study, we focused on high resolution image. So
my question is very simple. Why do you use transparency for research?
one more question.
In my view, Yamaboku Junko has a little transparent part, semi-transparent part. All of the object opaque, not transparent. So why do you use transparency when research? Very simple question.
Why the high resolution photo image must be transparent?
Probably to analyze the structure of the object, I think. I understand.
Okay, I have a question that, so now you want to say the high resolution image, right? So when you change the scale, I mean when you zoom in to see some details, so you need to increase the number of particles and then render it, right?
Yes.
For every time maybe when you change the viewpoint and when you zoom in or not. So the time you, I mean you change your viewpoint, for example, you have shown the image maybe the previous slide. Can you show me the previous slide? Previous. Maybe this one.
Sure.
Yeah. Zoom. You show the three pictures when you zoom in the image. So, I mean, when you zoom in, you need to prepare the particles again, right? I mean,
Yes, so
to increase the number of the particles.
in advance, so we prepare particle and
So you mean you prepare maybe a large set of particles, and you use maybe different number of particles depending on the viewpoint, right? Maybe I think it is that.
different point.
Yeah,
Yes, so
use different number of particles.
different points, so not same point. It's different points, different point generate.
Okay.
Maybe you are right.
Okay.
That's fun beforehand.
Okay.
In usual multiple resolution system, we cannot prepare for every cases. That is so in every kind of multiple resolution system.
Yeah.
We select some resolution.
I just want to know that.
For that case, we prepare.
Yeah. Okay. Thank you.
Sorry, it's a time now. So, yeah, next time, please, question. Okay, thank you very much. Last presenter,